is actually a problem. Let's see though. I think we've actually got our next speaker on here. Hello.
Hey, Shishir. My name is Shishir.
Welcome. Thanks for joining us today.
Yeah. Can you guys hear me okay?
Yeah.
Yes, we can hear you.
Sounds good. There was a little bit of hiccup, and I thought the session was going to start like at 4:25 or something, but I guess I can
No
start.
problem. No problem.
No worries. Thank you for being flexible. Yeah,
exactly.
Yeah.
When you're ready, you can share your screen. Just let us know when you're ready.
Sure. Give me a second.
Yeah, no problem.
So let me share my screen. And okay. So looks like yeah. Shall I start, or do we need to wait for someone?
Yep, whenever you're ready.
Okay, so hi, my name is Shishir, and I'm going to be presenting Nomad Driver Containerd for this session. A little bit about myself. Like I said, my name, and I'm an open source enthusiast. I contribute to a lot of open source projects. Most recently, I've been hacking around Nomad and HashiCorp stuff these days, but in the past, I have also contributed patches to Docker, Run C, and Containerd. I have also contributed patches to Node Control, and this is one project I would also be talking about along with the driver because it is of particular importance if you're trying to move from Docker to Containerd. I also authored some projects, and I will be talking about this particular one today. I work as a software engineer in Roblox. You can see this nice picture there, and we allow kids to build their own games, and we are a gaming platform company. So yeah, let's get started. So what does the current architecture look like? Uh, in the past or even today, when you launch a container using Docker, from the CLI or Nomad, you run a command like Docker run or Docker pull or something, and it goes to Docker daemon. And daemon is basically your Docker D, uh, which at that point figures out if, hey, you know what, is this a command related to container? If it is, let me delegate it to someone else who can do this stuff for me. And containerd is kind of that daemon which handles the container stuff for Docker. So the request comes to containerd, and containerd launches a shim process, which is a shared memory process, which tracks the state of the container in the lifecycle in case the container goes away. It stores the pipes and a lot more information so that it can reattach to the process. And then you see your run C, which is your actual container. So this is what it looks like with Docker. Now, the question is, do we need Docker at this point? Um, so the way Docker was designed as a monolithic service, and it initially started by doing a few little things, but over the period of time, they started doing a lot more, and they packed a lot more information into the application. Uh, they not only did container management, but they also did volume management, image management, security stuff. So a lot was packed into into this application, which became really heavy, and it was designed to cater to these two kind of workflows. Primarily, one was the developer workflow, which was at the build time, which is like, hey, I'm a developer and I want to build an image and I want to push it to the registry, right? So you go to your desktop and you write your Docker files, you do a Docker build, you build an image on the file system, and you do a Docker push. Boom, the image is in registry, ready to use. But then the other side of it is the runtime flow, which is running workload in production. Now that you have your image pushed into registry, you go into one of these orchestration systems like Kubernetes or Nomad, and you say, hey, this is my Docker image, and can I launch a workload into production? And then In Nomad, you launch this job, which goes to the scheduler. The scheduler will throw this job to a Nomad client, which will have a Docker task driver running, which will launch your workload for you. But in a sense, everything is packaged already in the image, right? So a lot of the orchestration systems started to realize that for number two, which is the runtime flow, we don't really need Docker. Docker is good for the build time. Developers can still use it to build the images and push it into the registry. But for runtime, all we need is a container supervisor or container runtime to launch the workload for us. And if you look at the previous picture, even Docker is actually delegating that to another daemon. So why not just talk directly to containerd and launch the containers for us? So orchestration systems like Kubernetes and Nomad actually derive more value from two than one. So I think the question is, do we really need Docker for two? Major players in container community like Red Hat, Cryo, Kubernetes, which uses CRI containerd, which is interface to containerd, are actually moving away from Docker. Some of them have already moved away from Docker. Most recently, Kubernetes also retired the support of Docker and directly integrated into containerd. Uh, so where are other orchestration systems going? As you can see, Kubernetes, I would like to just quickly open up some of these links. And as you can see, Kubernetes initially was integrating with Docker, but now it started integrating directly with containerd, and there is no Docker anymore. Similarly, for AWS Fargate, um, they directly are integrating with containerd. Same thing happened with Azure. A lot of paths that were built on top of Kubernetes and even Red Hat, OpenShift, which have their own runtime called CRIO, which under the hood integrates with some of their own container tooling and ecosystem like Podman, Scopio, and Build.ah. Most of them have actually moved away from Docker because of the benefits that containerd provides directly. Uh, so in general, the Kubernetes architecture looks very similar to this, where when you launch a pod, it goes to a master API server, and API server throws this pod onto a worker node, which is running kubelet. A kubelet now talks to an interface, which is basically your gateway to containerd, and it just launches your container to container. Containerd launches your container at that point. Until 1.0, it was a separate interface, and then they later on consumed it as a plugin. So I think the question is, what are the benefits of all this? Like, why are we doing this? Agreed that Kubernetes already moved away from this. Um, the benefits is usually smaller CPU and memory footprint. If you remember in the beginning, I talked about how Docker is a monolithic service. Containerd being more lightweight, you can see the pod startup times for containerd are much smaller. Even the kubelet and the actual runtime CPU and memory footprints are much, much small. And the way they achieve this is they don't do everything like Docker. They only do the container lifecycle management and image management, and the rest of the stuff could be delegated to other areas um, which are subject matter experts in those areas. So, for example, containerd manages the container and image management. For networking, usually people rely on CNI-based plugins. Volumes could be managed using CSI, which is the container storage interface, and containerd also provides some metrics as part of the API. So by keeping the scope well defined and minimal, they're able to keep the footprint really, really small and more lightweight. And that way is, they don't have a lot of bloat baked into the runtime. So this is the project that we wrote. We realized that initially it started with a issue on GitHub where someone was asking about it, and we realized that we also have very similar needs and we wanted to go on the same roadmap. We started building this project, which was basically a task driver for containerd, and very similar to any other job that you launch, where you specify your task driver as Docker or QEMU or Java. You specify your task driver as containerd driver, and Nomad server will launch this job to the client, which talks over to the task driver. And task driver at that point can directly talk to containerd or gRPC, launches the shim and the container, and the driver can manage the lifecycle for you. Um, so the other benefits it gives us, and this is something we have been exploring, so we haven't fully integrated into it, but AWS Firecracker has a native integration to Containerd. So people who are trying to integrate with other alternate container runtimes can actually integrate with AWS Firecracker. But this is probably an area we are still exploring. Contributions are always welcome if you want to work on it. Um, we have added the official documentation if you want to check it out under the Nomad GitHub page. So all the flags and everything is updated. The project is hosted on GitHub under Roblox umbrella. Just to give a quick overview of the flags, we have most of the flags. So what we are trying to achieve is we are trying to achieve feature parity with Docker. So people who are trying to migrate from Docker to Containerd, there's very minimal effort for them to integrate. Uh, so in a sense, when you launch a job using Docker, you have a job spec like this, and all you want is either to replace that Docker keyword with Containerd driver, and the rest of the flags, at least the idea is, should be very similar, if not same, and you should be able to launch a job without having Docker present on the system. Uh, some of the flags we have integrated in the past, which are very needed for launching a job, is like image, command, args, and entry point. Uh, you have a flag to specify your current working directory in the container when you launch it. To run your container in privilege mode, you can define your pitch limit, how many processes the container can launch in the container. You can have a PID mode, which is currently set to host. If you want to fall back on the host namespace, you can set your host name, host DNS. You can also enable seccom or use a custom seccom profile, which is for secure computing, which allows you to limit your syscalls. You can specify your shim size, which allows you to have a shared memory in case you have some performant applications running. Uh, you can change your file system into read-only mode. You can enable your host network, extra host, add and drop capabilities, pass on devices from the host. You can enable authentication if you are dealing with private registries. You can also mount volumes. So this is something if you are using Containerd driver and you have your CSI plugin, you already have a volume which is being created by your CSI plugin. You can actually mount that using the mount option. Uh, just take a look at the project, and I'm gonna do a small demo on this just to show you guys, and then I'm also going to be talking about the project that I was talking about, nerd control, and why this is really important. So I think let's start by launching a job first. So there's already a Vagrant VM provided as part of the repo. If you want to just try out the driver, all you need to do is you need to do Vagrant up, and it will basically spin up a Vagrant VM which has all the dependencies already installed in it. So you can just go and launch the example jobs right away. And there are descriptions around the example jobs. So you don't have to install any dependency. I just did a Vagrant up and then I did a Vagrant SSH, and now I'm ready to launch my job. But before I do that, I want to show, if you can see, there is no Docker on the system. So there's no Docker. The only registered drivers are Containerd driver exec and voidsec. And now I can launch a job, and meanwhile, let me just open a few other tabs. So now, as you can see, we just launched a job using Containerd driver, and that job is running. Nomad allow. Pull down the image and started, and you can check the logs, logs, uh, and you can see is the Redis server has started and is ready to accept connections. There are a lot more examples in the example directory. For example, running your jobs in privilege mode, uh, adding extra host or DNS, adding different capabilities, trying out the authentication and things like that. But I think one of the questions that pops up, hey, I am moving away from Docker to Containerd and I launch using Containerd. What happens to CLI? If I run into a problem, I'm more used to running the Docker CLI. How would I go about debugging my application? And that's where Node Control comes into picture. It is a project under Containerd umbrella, and what essentially it is a Docker compatible CLI for Containerd. What that means is you pretty much get the same commands and flags that you used to get with Docker, so that you don't have a bigger learning curve, and you can just run the same commands using Node Control. So to give an example, uh, we are running a job right now uh, called Redis, and I can do node control TF to see if I have a running container, or I can do node control images to see if I have images. And this pretty much looks like what Docker CLI used to look like, and it has pretty much everything, right? I can run a container, I can exec, I can logs, start, stop, kill, send signals, pull, push. It pretty much is the same thing. And now the neat thing is, if you're coming from Docker, you can actually add uh, alias to Docker, and I can just say alias Docker equal to node control and save it and source my file, and I can just run the same as I was running Docker, even though there's no Docker on the system. So there is no Docker on the system, but I can pretty much do Docker PS, I can do Docker images, and internally Docker is just an alias to node control, and the flags are pretty much the same. So if I want to launch a new container, I can just do ubuntu bin bash, and it will pull down the image for me, and it will start a container for me. Having, let's go back to the slides. So yeah, so this was the demo, and I would highly encourage you to try out the project. But having said that, uh, it is still in. We are still developing the project as a community. Uh, Docker is still a very stable driver, so I would suggest, even if you're starting in a production environment, you can run both the drivers, because Docker under the hood actually runs Containerd, so you don't have to install Containerd explicitly. All you have to do is just drop the driver, and then in your registers drivers, you can see both Docker and Containerd together. If you like what we are doing, you can watch updates on the project by clicking the watch button. Any issues and PRs, please start the project. It helps us, other users to discover the project on GitHub. We are always looking for contributors. We have a few external contributors on the project, but there is a lot more to do, and we want to develop this as a community project. If you want to contribute, just click on the fork button. You will have your own fork, and you can click the, you can open up here. When in doubt, click all three. I also have another project if you want to check out. Yeah, that's it. Thank you. I'm going to stop sharing. If anyone has any questions. I think I went pretty fast, probably.
No worries, no worries. So that means we have a lot of questions for you.
I hope so.
A couple of questions.
Sure.
Yeah. Jackie, do you want to start questions, or you have, oh, you have dog on there. All right. So I imagine there aren't too many direct resources for you to reference in building a task driver. Did you find any useful ones? Was there a reference that you found really helpful? I know you mentioned the Firecracker one, and I know you mentioned, there's an existing Docker task driver, but were there any other references that you were using that helped you develop your task driver?
Right. So actually, when we were developing our task driver, HashiCorp is very nice in promoting how to build a task driver. So they have this hello world kind of task driver skeleton project. and you can just download that project, and that becomes your reference point to start building the driver on top of it. I would say the documentation itself was really nice. The authoring guide of how to build a task driver. And I also suggest you guys are taking a session on how to build a task driver. So if someone wants to check that out, that would be helpful too.
Awesome. And what were some of the challenges that you encountered while you were developing it? I know Containerd, it has a schema, everything is there, but were there any challenges that you encountered as you were trying to integrate with it?
So I think, like from technical perspective, Containerd has been a very stable project, which is developed by a whole, very big community that is coming from the Docker and Kubernetes background. It is a very well maintained project. Technically, some of the challenges were like some of the features that were not in Containerd. If you have to open a PR to Containerd first before it can be exposed to the task driver. We also had some stability fixes that went on early, where if your task driver restarts all of a sudden, is it able to attach to the existing containers, or do you just lose your workloads? I think, but the bigger challenges were not on the technical side, which we are still facing, is around building a community. We are still a very small team compared to HashiCorp, who has, been building a Docker driver. So we still want external contributors to come and help us, and take it to the next level where this becomes a first-class citizen as Docker.
I guess speaking of contributions, I'm sorry, I'm doing my best over here. No, not the food. If somebody's interested in helping and contributing, what would be a good way for them to get started?
I think we have a bunch of issues which has been tagged as help wanted, but always reach out to me on email or Twitter, and we can hang out on Zoom. I'm more than happy to give background of the project, even walk you through the code base, to help you onboard on the project before you can start contributing. So yeah, from our side, we are pretty open. If you're interested and you have background in containers and Golang, yes, you'd be a right fit to contribute.
I also noticed you had Vagrant in there. And I know that a lot of the development work for Nomad can be done in Vagrant as well. I know that's part of that's something as part of the contribution process. You can have a self-contained Vagrant environment to test Nomad in. So for your Vagrant development setup, do you use it to test locally? Are you using it in a pipeline to do automated testing? What are the ways that you've been using the machine that you've been that sort of the sandbox that you've been creating for your task driver for testing specifically?
Right. So you're right. I just have to say I love Vagrant. It allows you to spin up a small instance, and you can just work around with it. For the local development, yes, you can just do a Vagrant up, like I mentioned, and it will spin up a Vagrant VM for you, and it will pretty much have Nomad and Containerd driver already running in it. So you can go inside it, work on your patch or PR, and if it works for you, you can test it locally, either using manual testing. There is also a test suite provided in there, so you can just do a run test, and it will run the test for you. For the CI/CD pipeline, we are, I think, using GHA, which is the GitHub Enterprise, GitHub Actions, and it basically every time you open a PR, it runs that test suite by launching various different jobs using the Containerd driver to make sure there's no regression, and that helps you to integrate easily. So someone who doesn't have a lot of background in the project, they might miss a few edge cases, but we are okay because that integration test suite help us pick up those bugs.
Awesome. Thank you so much, Ashir. We appreciate you joining us today and talking about how you Roblox have been building this Containerd task driver. We appreciate your contribution. And for those who are able to contribute back to it, please do. It sounds like it's a fantastic project and there's a lot of opportunity there. So I highly encourage it. I have yet to look at task drivers, so it's an opportunity for me to explore that as well. So thank you so much for joining us, Shashir.
Thank you. Bye-bye.
Bye. All right. So next up, we have, a Vagrant talk. Speaking of Vagrant, we're going to have Chris and Sophia tell us a little bit about building Vagrant 3.0. It has a lot of awesome improvements.